Okay, guys, we're gonna look at areas, or not areas, but properties of trapezoids and kites. Actually, second semester we'll do the areas of these, but first semester we're just going to look here at some of their properties. Yesterday, you remember we talked about rectangles, rhombuses, and squares. So today we're going to finish up the rest of the quadrilaterals that we had when we talked about first section of chapter 7, which are trapezoids and kites. Now, I'm not going to talk a whole lot, guys, about trapezoids. What I am going to talk a little bit about is an isosceles trapezoid, and we'll do a problem for an isosceles trapezoid here that will also be the same as a trapezoid. There's not a whole lot you're going to see with just a trapezoid other than the one problem that we'll talk about, but definitely we'll do a lot with isosceles trapezoids. We're going to talk about another little thing about trapezoids in the second page, and then we'll get the kites here for the last two slides. But one of the things I want to talk about first, which is, guys, what do we call the sides and angles of a trapezoid? So, guys, in any trapezoid, whether it's isosceles or not, the two sides that are parallel, we call those the bases. And then the other two sides we call legs. Now, in an isosceles trapezoid, the fact is that the legs are congruent. Okay? In a regular trapezoid, the legs are not congruent. That's the difference between a trapezoid and an isosceles trapezoid, is whether the legs are congruent or whether they're not. And then, in any trapezoid, there are two sets of base angles. Where the legs intersect one of the bases is a set of base angles, here and here. And then where the other base intersects the legs is another set of base angles. So you actually have two sets of base angles. So the first property of an isosceles trapezoid here is that the base angles are congruent. So in this picture here to the left, I know that angle A is congruent to angle D, okay, where this base and this leg intersect. The same base with the other leg intersect. That's one set of base angles that are congruent. And then there's another set of congruent base angles with the bottom base. So angle B is congruent to angle C here. And then the next property of an isosceles trapezoid is that the diagonals are congruent. So in this picture, segment AC, okay, this diagonal here is congruent to this diagonal here, congruent to segment DB. Let me ask you a question, guys. Do these diagonals bisect each other?
No.
No. Why? Because a trapezoid is not a what? It's not a parallelogram. That's right. So all those properties that we've really been hitting pretty hard for last week, you know, diagonals bisect each other. The opposite sides are congruent. The opposite sides parallel. The opposite angles congruent. That doesn't apply to these. These are not parallelograms. This is a different kind of family of the quadrilaterals. So one thing you need to keep in mind is that neither of these things we're talking about today, a trapezoid or a kite, those are not parallelograms. And I know you're thinking, man, we hit those properties really hard. We did. But you kind of have to shut them off here because they don't work here. They work for everything else we talked about, but they don't work here. Okay, let's look at, I've got a couple of examples here just below for an isosceles trapezoid. And really, they both go back up to these pictures here. Okay, the first one is this. If angle A is 115, we need to find angle B, angle C, angle D. We want to find the measure of those other four angles. So, one of those ought to be pretty easy. What one do we know right now pretty easily? Angle D, right? What's angle D got to be? 115, absolutely. Why? Because the base angles are congruent. Yeah, absolutely. Those base angles are congruent. They're both 115. Now, here's where we kind of get into a little bit of a conundrum, which is, how do I find angle B? How do I find angle C?
65.
Okay, Bailey, how do you know it's 65?
Because you subtract 115 from 180.
Why 180 minus 115? I would agree with you.
Because 180 is a flat line, and those two make a flat line.
Angle B and angle A make a flat line?
Yeah. If you add their angles together, they do.
That may be the case, but I'm not sure that's a great explanation for what's going on here. What's maybe a better explanation for what's going on here? What do you see right here, guys? You like how I always put the emphasis on a C when I say that? What do you see right here, guys? You see a C there, right? What kind of angles are those? What kind of angles are those that make that little C looking thing? What do we call those? Consecutive interiors or same side interiors, right? Are the lines parallel? Yeah, those are definitely, this is a trapezoid, which it is. We know those two bases are parallel. So we know those same side interiors are supplementary. That's why it's 180 minus 15, because they make same side interior angles, or your book calls them consecutive interior angles, and they're supplementary. Guess what angle C is? Yeah, it's 65. You can say, oh, you got a C over here, same thing, or you can say, hey, the base angles are congruent. Now, here's what I got before. Here's what I've gotten before. Ms. Frickmuller, you said that the properties for a parallelogram doesn't work, but we learned at parallelogram the consecutive angles are supplementary. You're right, the consecutive angles are supplementary, but are the consecutive angles supplementary here? Are those two supplementary, 115, 115? No. So you do have some supplementary angles here. It's just not always the consecutive angles. Yes, those are consecutive and supplementary. Yes, those are consecutive and supplementary, C and D. But that does not work for all of the consecutive angles. Okay, guys, here is really the one problem that you're going to see on just plain Jane trapezoids. Okay, if they give you a trapezoid, probably the only thing they can do is give you a couple of angles like this that are same side interior angles, like the 115 and 65 that you're trying to find the measure of. Okay, let's do this last one here, which is if AC equals 3x plus 15 and BD equals 12x minus 21, how would I find x in the measure of each diagonal? Well, look, guys, what's true about AC and BD? They're what? They're congruent, right? Those are the diagonals of an isosceles trapezoid. So I know that those are congruent. So to solve for x, what do? That's it. We just set them equal to each other. Okay, so we're going to subtract 3x. We get 15 equals 2x minus 21. Add 21. Whoops. Why did I write 2x there? Somebody yell at me next time, will you? That's not 2x. What am I thinking? That's what? 9x. Man, I'm not even sure why I thought that was 2x. 36 equals 9x. We divide by 9. X is what here? 4, right? How am I going to find the measure of each diagonal then? If I found x to be 4, how do I find the diagonals? Just plug them in, right? Does it matter which one where I plug it in? Nope. So let's do the first one. That's probably the easiest. 3 times 4 plus 15. That's 12 plus 15. So the diagonals are what here? 27. Should I get the same thing if I put x in for the other one? Yeah, I will. 12 times 4 is 48. 48 minus 21 is 27. Okay? Questions? Okay, let's talk about something called the median of a trapezoid. Okay, this is called the median of a trapezoid. Sometimes, and I've seen this in some books will call this the mid-segment. And I only know this because I've seen a book that's called it the mid-segment of a trapezoid. It's the same thing. The median of a trapezoid, the mid-segment of a trapezoid. Guys, once again, this does not have to be an isosceles trapezoid. This works for any trapezoid. And what a median does, or a mid-segment, it connects the midpoints of the legs. And it has 2 properties. Number 1, it's parallel to the bases. Frankly, we won't deal with that. We're just going to deal with the second property, which is that it is the average of the bases. That means to find the length of this median, I'm going to average the bases. So I'm going to add the 2 bases up, base 1 plus base 2, and divide by 2. Maybe not the best thing to say as far as average of the bases. It's the mean of the bases, technically, if you want to talk about measures of central tendency. It's the same thing, just different word. So let's look at a couple problems that we have here. You're going to see one of these on your assignment tonight. How would I find x here? Yeah, x is my median, so I'll just put x in here. 35 and 43 are my bases. Doesn't matter which base is which. So 35 plus 43, then divide by 2. That's what? 78 divided by 2. That's what? 39. Okay. So x is 39 for that problem. That's pretty simple, isn't it? Not too bad. Let's do this one here. Ooh. Wow, this one's a little different. What do they give me here? 12 is what? One of the bases. What's 15? Yeah, this is the mid-segment or the median, right? And then y is my what? My other base. Excuse me. So now I'm going to just use the same formula here, but instead of x being in for m, it's 15 now. So that's what? 12 plus y is my 2 bases, divide by 2. What are you going to do here to solve? Yeah, let's multiply both sides by 2. Let's get rid of that fraction. So that's what? 30 equals 12 plus y. Subtract 12. We get y equals what here? 18. What's 18 plus 12? 30, right? What's 30 divided by 2? 15. Yeah, that's what the median was. Good. Okay, this actually has kind of some cool applications, which you'll talk about in your assignment today, but they draw a picture for you too, so it's pretty clear. Okay, let's talk about a kite now. And I did put the definition of a kite up here. It's been a while since we talked about it. But guys, a kite is a quadrilateral with adjacent sides that are congruent, and you have no sides that are parallel. And a kite really just has one very simple property, which is the fact that the diagonals are perpendicular. Which makes you think it's a lot like a rhombus. It's actually closer to a rhombus than you think, but that's really the only similarity, is that the diagonals are perpendicular. That's it. Well, I know you look at that and you're going to say, wow, Mr. McMorrow, that's going to be really easy. It actually has a lot more to it than that. And let me draw a couple things here for you. We just want to talk about a couple things. What do you see there? A couple of what? A couple of triangles. What kind of triangles are they? Yeah, they're right triangles, correct? What's true about those triangles? What's true about those triangles? Yeah.
Right triangles.
They're both right triangles, yeah. What else do you think is true? They're congruent. Yeah, they are congruent. Well, how are they congruent? Does anybody remember why these two triangles would be congruent? You're saying side angle side. I don't think it's side angle side here. I don't think it's side angle side angle. I don't think that's it. Yeah, this is hypotenuse leg. Good. Notice you got the hypotenuse is congruent here. That's part of the kite. And then they share this leg in common. Now, guys, let's remember this. Because those two triangles are congruent, what do I know is true about their parts? That's right, their parts are congruent. Why are their parts congruent? Do you remember that theorem? Somebody's saying it. Yeah, CPCTC, absolutely. Okay, so guess what? In this picture, in this kite, this angle is congruent to this angle. Why? Because of CPCTC. Those are corresponding parts of congruent triangles, so they're congruent. Guess what? This side is congruent to this side by CPCTC. This angle is congruent to this angle by CPCTC. Let's look at and I'm tracing these a lot better this period. Practice. What's true about those two triangles? They're right triangles, absolutely. What else is true? They are, congruent by, this is another HL one again. You got the hypotenuses, and they share this leg in common. So, I think I'm on 5 tick marks. So guess what's true about all their parts? Their parts are congruent by CPCTC. So this angle is congruent to this angle. These angles right here are congruent to this angle right here. 4 arc marks. That's a lot to make. So guys, I want to talk real quick about something that'll help you with all of this, which is this thing right here. This, guys, is the long diagonal. And it does a couple of things in a kite that'll really help you remember these things. First of all, what do you notice it does to the angles of the kite? What does the long diagonal do to the angles of the kite there? Somebody said it. Yeah, bisects them. So the long diagonal bisects the angles of the kite. Okay, and it does one more thing, and it's right here, right here. What does it do to that short diagonal? Yeah, it bisects it. Very good. It bisects the short diagonal. I don't know why I'm using a capital D, but I am. Hey guys, does the short diagonal bisect the long diagonal? Does the short diagonal bisect the long diagonal? I don't think so. Are those two segments congruent? No. Does the short diagonal bisect the angles of the kite? Are those two angles congruent there and there? No. So guys, this only works for the short diagonal, the long diagonal, not the short diagonal. Okay? The short diagonal does not bisect the long diagonal. Short diagonal does not bisect the angles. This only works for the long diagonal. Now, some of you are going to say, how do I know if it's a short diagonal or long diagonal? Guys, because of the way a kite is drawn, you ought to be able to tell pretty easily which one's the short and which one's the long. Okay, let me do a couple problems with the a kite here. And yes, we got a lot of stuff going on in here, but we're going to find A, we're going to find X, we're going to find Y, we're going to find Z, and we're going to find W. I think a lot of these are going to be pretty easy. Z and W might be a little bit tougher. What about A? Anybody know what A is? Yeah, A is 6. Remember, this is the long diagonal right here. It bisects that short diagonal. So that's 6, A is 6. Good. What's X? 15. Once again, the long diagonal here, it bisects that angle of a kite. So what is Y then? Yeah, 30. It bisects both of the angles here. Okay, what's Z? That might be one that you got to do a little bit of math there. It's not 30. It's 60, right? How did we get 60 here? Yeah, look, we've got what kind of triangle here? Yeah, let's remember that the diagonals are perpendicular. So 90 plus 30 is 120. Okay, and then we subtract that from 180. So we know Z is 60. Good. Okay, now W, guys, this is kind of hard to tell here, but W is this whole big angle right here, which is what I want. What is that whole large angle there? You are absolutely right, Mr. Newcomb. What'd you say again? 135. Now, I'm going to tell you there's a couple different ways you can get this. One way that you might have done is you said, hey, I know that's 60. I know CPCTC means this angle is 60. You could read that. You say, I know that angle's 15, I know that angle's 90, so I got another right triangle right down here. So 90 and 15 is 105. Subtract that from 180, we get 75. So this angle right here is 75. And then add 75 and 60 together, you get 135 for W. Now, I'm going to tell you another way that I think you need to think about this. And I'm going to kind of redraw this kite a little differently. This is W right here. We know this angle's 30. We know this angle up here is 15. By the way, what's true about, if I just draw the long diagonal here, which is something we talked about last class, what's true about these two triangles? Yeah, notice this side's congruent to this side, this side's congruent to this side, this side's congruent to itself. These two triangles are actually congruent by side, side, side. So you actually have another set of congruent triangles here if you just draw the long diagonal and that's it. Which means this angle up here and this angle here at W are congruent. So if that's 30, that's 30. We know that's 15. Either way we go, we can do 30 plus 15, which is 45. Subtract that from 180, because the triangle equals 180. We get 135. So don't be afraid sometimes to look at the big triangles, maybe forget about the short diagonal. And definitely, guys, today or tomorrow, you're going to see a picture that just has the long diagonal drawn. And so knowing that these two triangles are congruent, and knowing that these angles are congruent here by CPCTC will certainly help you. Questions?